That's the face you have to make it your iPhone to get it to leave a certain screen. I found that out just like a little while ago. It was like facial recognition requires that you make some kind of, you have to be incredibly furious at that point. Today on Secure Digital Life, we have Fletcher Heisler, who's going to talk to us about secure coding, which is one of those really bad words. Like it's a word so bad. Like when we hear the word secure coding, you almost expect that like the president would say it, but maybe not. So stick around for Secure Digital Life.
This is a Security Weekly production.
Welcome to Secure Digital Life. And you type in AAA porn or whatever it is you're typing in. I'm sorry. I was at a PG show.
And I'm really excited to be here.
I'm glad you're here because somebody needs to know what's going on.
That's right.
Okay, so now
Somebody has to drink this.
it's another day. It's another episode.
Yeah, he's looking at the wrong camera.
Oh, you put my camera over here. Cut. Basically, forget you ever saw that. I think actually forgetting you ever saw that would really be a good idea at this point. Secure coding. I mean, literally. The last couple of weeks you've been hearing me talk about the mysterious Leo who will never be on the show unless he appears from some afterlife. But we've been talking about how architecture kind of evolved into problematic situations in the future. And secure coding was never something that actually existed because it was just not something that was even considered. Joining me today, Russ, who is in some kind of like time warp Doctor Who studio there with cool artwork on the walls. He's visiting us from another domain, possibly another time or realm.
Also
Hi, Russ.
my office.
Oh, that's your office. Okay.
Yeah.
Your office changes all the time. It's like the studio. It's different every week, and you just never know what's going to be there. And Fletcher Heisler. Hi, Fletcher. Say hi.
Hey, Doug.
Hey.
Yeah, thanks for having me.
You have everybody has artwork on the wall. It's like you have like
I'm a little jealous of the penguin and the soldering iron, to be honest.
We have all kinds of cool stuff. Yeah, we have our copy of Sneakers on VHS. We have all my books from ancient stuff all the way forward. I haven't brought in my like 1956 guide to programming Fortran, but I have it somewhere. You never know when that's going to come in handy. Mm-hmm. So you're a secure coding guy, Fletcher. That's been something that we hear a lot about. I was hearing that from the congressman last week. I hear it from Washington. I hear it from corporate. What do you think secure coding is? I know that question wasn't on the list, but hey, gotcha.
Sure. Yeah, I mean, so I came from more of a development background, getting into security after that, as you know, in the security world, there's no perfect solution. We're all going to get hacked. It's all a matter of time. It's really just, where on the spectrum do you fit in terms of how hackable are you, and how much do you care? It's all sort of a set of trade-offs. So secure coding doesn't mean totally unhackable code. It really just means you're putting a priority on making sure that it's a little tougher to get through. You're not writing code that has known vulnerabilities. It's full of holes. It's at the end of the day, someone could very easily come in and poke holes and cause a lot of damage. As opposed to secure coding, you're at least aware of what might happen and taking some reasonable steps to prevent that ahead of time.
Well, you know that when marketing gets a hold of what you said, all they heard was blah blah blah, invulnerable to hacking, blah blah blah, perfect code, and that's what'll be on the that's what'll be on the box flyer they hand out at the conference, like perfect code that cannot be hacked. Yeah, and
that's of course what a lot of vendors will promise as well, and a lot of companies are spending oodles of dollars on we can just run our code through this system, and it's totally impermeable now. Well, and at the end of the day, it's kind of a garbage in, garbage out problem. Like, yes, there are lots of vendor products that can help out a lot, and it's not a bad idea to use them, use a firewall, etc.
What
if
about
you're writing really bad code?
What about you, Russ?
You're going to get caught regardless.
Russ, do you write secure code?
I don't actually write code much anymore. But if I did, I would make sure it was secure.
Well, there you go. I bet. That's what we all say, right? But I mean, I came from the coding world of just make it work, which was, that's where all these problems sort of came from, that pipeline, not my code, of course, but from that pipeline of we're isolated. I write a solution to a problem that's very isolated in a bubble, and no one ever has access to it except the people I allow to have access to it. And that all changed, and suddenly everyone can touch this stuff from all over the place, and it kind of gets that icky, that pole in the subway feeling to it.
And that's like the difference between, Doug, you're talking about dev and production, and on a development framework or area, I mean, that's where it's good to make sure, things work. And then when making it in production, I assume, Fletcher, am I on the right track? When putting into production, you want to make sure that it's much more secure.
Well, it all depends on your use case, right? Because again, it's all trade-offs. So if you're writing code for a brand new startup, and it might all be completely different next week, and you're really just talking to one or two customers, at the end of the day, if you're spending 3 times as much time making sure it's very secure, you're probably not doing things right. On the other end of the spectrum, if you're writing, I don't want to bring up the Hawaii emergency response that everyone's talking about, but you can imagine lots of cases where because who knows where fingers are to be pointed there. It's a complex system. Not
to mention the shot of it.
If you are spending some time on tests, on security, on all the right production things to make sure that everything goes as expected.
But I mean, all the time.
Yeah, go ahead.
All the time we see, in the real world as developers, we're going to release a product, and now we need to patch the product, and now we need to add this to the product, and the whole thing where you can push the button and don't have to actually do very much needs to be fixed. So now we're going to code that, and of course I know how those orders come down the ladder. They come to me and they say, code it, fix it, make the button turn red instead of green, and there's not, and we need that done right now. There's not a lot of time to say, I'm going to go through this long, drawn-out development process of 5 years where I'm going to figure out all these little ins and outs. And so I think that's where the whole secure coding idea comes from, is that has to be inherent in the system. It can't be this sort of bolted-on piece that will never, ever, ever get done. I mean, we'll put it on our chart.
Right. You can't just tack it on later.
Right.
But unlike, say, writing a bunch of automated tests that are inevitably going to take more time, there are a lot of security best practices that don't take extra time. It's really just about how you approach a problem. So, SQL injection is still the number one vulnerability out there. And if you're writing pure SQL queries by hand in the back end of your code, it's probably going to take you about as long as if you protected how those queries are being built in the first place. It's just a matter of knowing what to look out for and what patterns to follow a lot of the time.
So you started a company to do this, right? So you wanted to teach people how to be better coders or how to learn to be better coders. I'm sure we could all use some of that. The company's called Hunter2.com, which I saw the name and I wasn't sure where the name came from. Where did it come from?
Yeah, so Hunter2 is sort of an old security meme from back in sort of IRC logs, back in the days of, some people still use IRC. But online chat, where people are still figuring out how this whole internet things works. Someone says, if you type in your password into this little box, it shows up as stars. See? Star, star, star. And somebody responds with Hunter2. And there's a whole conversation about, but when you type in Hunter2, all I see are stars here. But how did you see? So anyway, now whenever security folks are half-jokingly saying, what's your password? The answer is Hunter2. So again, the idea being best practices. Hopefully it strikes a chord for some folks who have that background knowledge.
Well, we certainly like inside jokes and obscure references to strange things here on our shows. We're always coming up with new ones and hacker trivia items from bizarre movies that were made a long time ago and seeing who knows what that is. So what's the purpose of Hunter2? I mean, what are you trying to do there? Are you if I go to Hunter2 and I sit down and I push a button, am I going to suddenly be a better coder, or what do I need? What am I going to do?
Absolutely, 100% impermeable code. No, not quite.
That's what I figured. Marketing, perfect.
We're focused on businesses, schools, teams of developers, where they want to make sure that everyone on the team has these fundamental skills, knows what patterns to look for, and it's all through online labs that are all hands-on. So you can go to a weekend course, you can read a book and so forth, and all those things are good. But until you're actually performing those actions, you're exploiting code, you're patching code in your tech stack as well, it doesn't really stick necessarily. And a lot of what's missing to me right now in security education is an update to the tools. A lot of web applications are now single-page apps, mobile, hybrid, etc., using frameworks, JavaScript frameworks like Node all over the place that are changing very, very frequently. And therefore, the possible attack surface, the vulnerabilities being introduced, are also changing very quickly. And the training is built to focus on, for instance, you are a team of Node.js developers. You might have heard of SQL injection, but how does that actually relate to how you're working with a SQL database? And it usually comes down to be aware of the best ways to use the right libraries, the ways to configure your setup that don't necessarily have a lot to do with computer science concepts. It's not at the algorithms level of what's happening, but it's more just industry best practices for your particular tech stack. So you can go online, you can go through the labs, you can first off exploit, because it's very important to think like a hacker does and to see it in action and see what's possible, right? And you can touch code and see the difference, see it live.
So these are just like labs I can play with. So it's like the old third pigs and all those things that used to be out there that you could go in and learn to hack or whatever. But this is more about trying to make your coding like modules better for your web pages. Is that fair?
Yeah. So it's primarily focused on the OWASP top 10.
Okay.
So the OWASP comes up with a list of top 10 vulnerabilities.
Right.
As they take a big survey every few years and say, this is what we see in the wild. These are really common vulnerabilities and attack points that the different web applications are subjected to all over the place. And then we apply those to your tech stack. So we say, for instance, you're working JavaScript or you have a Python Django app. What does that mean for you? And how is that commonly done? What tools are typically used there, and how are they typically used incorrectly as well?
Mm. So if I wanted to become a web developer, which I'm not, but if I wanted to become a web developer, which language would I start with, like right now? Python?
I am a Python guy through and through. I mentioned Node because I think it's gaining a lot of popularity in general web development. I actually started a business 5 or 6 years ago now called Real Python. And we have, if you go out to realpython.com, we have a bunch of blog posts that'll help get you started as well for free. But I think Python is a really fantastic language for just getting started quickly. People joke that it's like writing pseudocode, meaning that you just kind of write out what your idea is in plain enough language, and it's pretty close to Python already, as opposed to if you were to start in something like C++. You'll pick up the fundamentals, but it'll be a much steeper learning curve because there are a lot more things to figure out before you can even print a string of text to the screen. In Python, it's print that string.
Well, yeah, I like Python. What about Ruby? What do you think about that?
Only on Rails.
I tried out Ruby, and Rails is the sort of common web framework around Ruby
on Rails.
Very similar.
Yeah, I wrote a bunch of like code for a class, and I was teaching a class, and I wrote a bunch of Ruby on Rails code for it. I thought it was easy. Yeah, and I've done Python too.
It all depends on personal preference. To me, Ruby is a less intuitive in that, once I know the syntax, once I know the right command to use, then I'm fine. But I would never guess it. And I find myself guessing the correct syntax in Python all the time, which is really a handy feature to have.
Russ, what's your favorite language in web development, or do you have one?
Well, I've been using XML a lot, and that's just basic for me. XML and HTML5. I come from back in the day when I was coding web pages. I think I was on HTML2 when I did my master's thesis. So we've come a long way, and I for interactivity and functionality, I used to love Flash with ActionScript, which at the end there became more a lot like JavaScript. But now with HTML5, I can do everything I want to do in that language. So
yeah, I started out in QBasic, and I still kind of miss it sometimes. And I think, if I just had a go-to statement, it'd be great. It's funny you mentioned XML.
Okay, if we're going to do this, and I get to win every time, so Fortran 2, baby. Like punch tape even. It wasn't even punch cards. It was punch tapes. It was big, long reels of paper tape that little things punched in it. Yeah, so let's not start this stuff about, back in the day. I know how you guys are going to do that. It's like, these kids today have it easy. Yeah, but anyway, right? So okay, so Fletcher, what? Yeah, that was. What three things do you think that people should have to begin to be secure coders? So I mean, like, okay, so a lot of our viewers maybe aren't going to be like, oh yeah, well, when I got tired of C++, I moved on. I mean, it's more like I'm getting started this. So what three skills do you think somebody should have to get into this?
Sure. So I think the step 0 is kind of choose a language and get familiar with all of the ins and outs. You need to be familiar with the tech stack. You need to know basic syntax, basic best practices before you even approach some of the security topics as they relate to that language. It's good to have that as a conceptual framework of, for instance, injection attacks. What does that mean? How should I be looking at them? But until you really understand, here are the couple different ways that I might, return results from a function in this language.
Right.
Then it doesn't really make sense to dive in further. The next that I would mention is probably third-party dependencies. So this is also one of the OWASP top 10, is I think they call it using known vulnerabilities. It's so easy nowadays, which is dangerous, to be able to just tag in someone's code, import a module, install a package, and have that functionality right out of the box for you. But getting used to reading documentation, it's not always fun, but it's necessary. And getting used to figuring out, what are the details of what I'm configuring here? What are the defaults? Do they make sense for me? What are the warning labels that this comes with before I just dive in and say, oh, great, I have OAuth. I can now authenticate using Google and GitHub and so forth for my application. Great, but do you really know how that's working? A little bit behind the scenes.
I'm going to add one to that, which is the same thing, but I want to add one for the viewers. One of those is learn to read code. Not just write code. You have to learn to read code. And in computer science majors, people always had to take a class called algorithm analysis or algorithms or something, and it's this big, thick book, and they make you learn to read code. And this is what you're talking about third party. I call it black box appy. The black box appy problem is I go out and I grab something someone else did, and I mod my codes. This is what people are doing. And when you do that, you have no idea what that black box appy is going to do, but you can often look at the code because they wouldn't let you have it otherwise. So if you're looking at it, but then you go, wow, it's big and complicated and I don't know what I'm doing, and that's where the big problem is going to get embedded in your software.
Yep. Yeah, and reading code is almost a separate skill from writing code
to
an extent. You need to be able to look over something that isn't structured the way you might have done. And it's kind of like speed reading as opposed to really analyzing a text. You need to figure out where you might want to look for the right catches.
And that was a job title even. That used to be called a system analyst. I mean, that was what, if you had that job, your job was looking at other people's code and analyzing it rather than writing code typically. So when I was looking at people's code, I was trying to figure out what it was going to do. And that both came up because of evolution, where, old Bill wrote all the code for the company, and now old Bill got hit by a subway on the way home. And so I just took over to, I've got 19 programmers who are all writing pieces of this giant thing, and we're plugging them all together, and nobody really knows how they all work. We just hope that they do.
Yeah. The last piece I'd mention, if you're just getting started, it's great to go to a 1 or 2 day course, find a mentor, get some bulk knowledge.
Mhm.
But in general, this is the kind of stuff that it's best to learn a little bit at a time over time, and it takes a long time. It's a wide subject, right? So
That's true.
you're not just going to sit down one day and learn all things there are to know about secure code or even about your particular tech stack, which is part of why we built these labs to be able to dive in for an hour or two a week and pick up some knowledge that's relevant in a very, very quickly changing industry. Instead of a lot of people treat ongoing training, especially in security, as sort of a once and done, more compliance focused. That we did our annual training, so we're good because we spent a day or two in it.
Right.
If you're going to pick up these difficult skills, it's best to visit them, maybe with a lighter touch, but frequently.
Well, I'll tell you from observation, a lot of times in companies, what you'll see is this is treated like that sort of, oh, yeah, and they send everybody to that 1 hour online seminar on secure coding, and then everybody goes back to work and says, yeah, I checked the box, I did my 1 hour seminar, and now I'm back to business as usual, and that's why we have a lot of these problems, because that's been the way this has been done. I'm going to ask you and Russ one last question. So, Computer Science 1 has been taught the same way forever. I mean, it's literally taught pretty much the same. The language changed, but the rules are pretty much the same. And to some degree, I completely agree with that, because at some point you just have to learn how to write a sort or a linked list or whatever. And I don't see how you can ever be or call yourself a coder if you can't do those basic skills. I mean, it's just sort of embarrassing when you see people coding and you say, oh, why didn't you use this? And they go, what's that? And it's like, it's like when you ask networking people and you go, why do you have your subnet mask set this way? And they go, that's just supposed to be 255, right? And then you kind of laugh and go, wow. So how would you and Russ teach Computer Science 1 if you could just do it any way you wanted? I mean, what would make the world a better place? Or maybe you wouldn't change a thing, and it's like, just learn it, and then later we'll worry about this.
Fletcher, you want to take this as the expert? You want to take this, and I'll just tack on.
I have some thoughts. I guess it's a bit of a trick question in that it depends. Well, I guess my non-answer is I'm not sure if I would first teach Computer Science 1. So again, I would.
That's
start
okay. You could say that.
The practicalities of let's get you programming, let's get you seeing results. I learned by doing. And I actually remember after my early adventures in QBasic, where I was making, pretty colors fly around on the screen, that was very encouraging. That was exciting. That was fun. Then I took, I was still very young, and I took a quick sort of 3-day course in, I think it was C++, and it was so boring. But the problem was they didn't really explain, here's why you need to set up all these things, here's why it will matter. We never really got to, here's why we're doing all this in the first place. So I think a lot of the time, if you start with algorithms, you start with here's a linked list, but you don't, get people involved in here's what we're going to get out of this exercise. Here are all the amazing things that are possible afterward. It's hard to hook people into the excitement that is programming and computer science. So I would kind of start from the back end and say, here are some great projects. Now let's dive in and figure out how they're working on the underside, right? Let's create something amazing.
That's what Scratch,
like Python.
Scratch and some of those kind of languages were designed to do, was to let people sort of see, wow, I'd like to make a fun little game, and they don't really understand how it fits together, but it's like, and then later you have to sort of deeper dive and say, well, I don't like it being a box, I wish it was a sphere, and it's like, oh, how do you build that object? And it sort of gets weirder and weirder.
Yeah.
Russ?
Yeah, and then once you're into it at a necessity, you start diving deeper.
Yeah. Russ?
One of the things that I've noticed lately is because I'm involved with working with students who are doing these things called road coding or coding at the public libraries and things of that nature, is the younger that they are, they're calling these activities coding when really what they are is just exercises in logic. So I had gotten a friend of mine. Her daughter wanted this. It's supposedly teach a 6-year-old how to code, But really what it is it's a mouse that you use the buttons on it to control move forward one square, and you would hit the buttons on the mouse and then hit run, and then it would execute the program. And yes, we can say that it is a program. Of course it is loosely, but really it's more of an exercise in logic. So I kind of think that if the younger generation is getting started, they might want to get started with understanding what logic is, inductive and deductive reasoning, and then move to understanding or maybe even practicing some sort of language. Like I've been using CSS or HTML as basic, and then even Python, as you were saying, Fletcher, that's been pretty easy or straightforward to use with some of my non-credit students. And it's pretty close. The syntax is pretty close when you just kind of tell it what to do. So it sounds
like the sneaky way is best. I remember my daughter was little and she was at school and she came home and she was doing these problems they gave them to do, like, how many people had apples at lunch or something like that. And what they were doing was they were sneakily teaching them statistics, by making them ask questions. So they didn't just come in and go, here's the formula, use it. They came in and said, okay. I mean, my only problem with that whole thing, and I agree with it, but my only problem with that in computer science is that when people evolutionarily learn to code, a lot of times their code is just Wild West spaghetti code, and they aren't very structured with it. They just and they have their own way, and that's both good and bad, because sometimes they come up with better ways to do it, and sometimes I remember a student showing me his copy of Towers of Hanoi one time, and it was like this thick. And I don't know if the viewers are familiar with Towers of Hanoi, but it's an old computer science problem. And if you know how to write it with a recursion, it's like this long. And if you don't, it's like this stack of paper. And, and so sometimes it's good and bad to be sneaky like this. But I do like the idea, and I think it works, because you dig deeper and you start saying, I need to learn the math. And eventually, hopefully, people are going, wow, I really need to know matrix algebra so I can do regressions or whatever. Yeah?
Yeah, I think a lot of that is also learning to work on a team. If we're just talking about CS1, then it's enough to get you hooked and to figure out maybe not how to write the best code, but how to get the job done.
Well, yeah.
But yeah, once you're working in a team, you're sharing code, you're debugging someone else's and reviewing. Then it really counts to know all the best ways to do something and to organize and document it.
Well, yeah.
Documentation. Yeah, I was going to say that too. That's so important, and because so many people have so many different hands in the code and in development. One person's not writing 2 million lines of code for Windows or whatever it might be. In documenting each of the subroutines and so on and so forth, very, very important for community and group work.
I completely agree. So, thank you, Fletcher, for joining us, hunter2.com. Go check it out if you're interested in learning to be a better and more secure coder. Thank you for joining us from the other dimension, Russ, which is your office and TARDIS and whatever. And thank you for joining us and listening to all our babble for 25 minutes. And we'll see you next time on Secure Digital Life.